This video series goes through the daily problems in this maths calendar that is published by the American Mathematical Society. You can either purchase it through their website or via Amazon. Today's question concerns 4 positive integers that satisfy the following 4 equations. Firstly, a times b times c times d equals 8 factorial, where of course 8 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. AB plus A plus B equals 524. BC plus B plus C equals 146. And CD plus C plus D equals 104. We will solve for A, B, C and D, but technically the question only asks us to find A minus C. Finding all complex valued solutions to these 4 equations would be a problem in algebraic geometry and can be solved symbolically using a computer. However, we are after integer solutions, which suggests that somehow factorizations of these numbers should come into play. The trick then is to recognize that AB plus A plus B can be written as A plus 1 in brackets times B plus 1 in brackets minus 1. Indeed, expanding out the brackets, we get AB plus A plus B plus 1, so we subtract the 1 to cancel the extra plus 1 that we get. By adding 1 to the right-hand side of the last 3 equations on the last page, we get that A plus 1 all times B plus 1 is equal to 525. B plus 1 all times C plus 1 is equal to 147. And C plus 1 all times D plus 1 equals 105. Since we're after integer solutions, we then compute the prime factorization for each of those 3 numbers. Because each of A, B, C and D are positive integers, the smallest they could be is 1, and so the smallest one of them plus 1 could be is 2. Therefore, each of the 2 terms on the left-hand side must contain at least one of the factors on the right-hand side, and by uniqueness of prime factorization, each of these factors on the right-hand side must occur in one of the 2 terms on the left-hand side. Looking at the second line, we have got 3 factors, 3 times 7 times 7. So therefore, there are 3 possibilities. B plus 1, it could be 3, it could be 7, or it could be 3 times 7. It cannot be 7 squared, because if B plus 1 were 7 squared, then in the first line we see that we have got a factor of 7 squared on the left-hand side, but we only have a single 7 on the right-hand side, so that would not work. We list the 3 possibilities down here for B plus 1. C plus 1 must be the remaining factors. So if B plus 1 is 3, then C plus 1 must be 7 squared. If B plus 1 is 7, then C plus 1 must be 3 times 7. And if B plus 1 is 3 times 7, then C plus 1 must be 7. For the same reason that B plus 1 could not be 7 squared, we find that this first possibility can't actually occur, because if C plus 1 were 7 squared, then the left-hand side of the last line would have a 7 squared on the left-hand side, but only a 7 on the right-hand side. Given that prime factorizations are unique, this is not possible. The second and third possibilities both work out. If B plus 1 is 7, then from the first equation we see that if B plus 1 is 7, then A plus 1 must be the remaining factors, or 3 times 5 squared. We therefore put this in our table under A plus 1. Similarly, if C plus 1 is 3 times 7, then from the last equation we see that D plus 1 has to be the remaining factor, that is 5, so D plus 1 is 5. For the very last possibility, if B plus 1 is 3 times 7, then from the first expression 3 times 7's been used, so a plus 1 has to be 5 squared. And from the last equation, if c plus 1 is 7, then d plus 1 has to be the remaining factors, 3 times 5. In the original question, there's one more equation. We are told that a times b times c times d is 8 factorial. So we need to test these two possibilities to see whether they also satisfy a, b, c, d is equal to 8 factorial. If b plus 1 is 7, then b is 6. If c plus 1 is 21, then c is 20, and so forth. We can determine from this table the possibilities for a, b, c, and d. I've written them in terms of this factorization here, so it's very easy to see which possibilities also satisfy a, b, c, d being 8 factorial. Since this middle possibility here, a would contain a factor of 37, clearly the product of these numbers cannot be 8 factorial. The last possibility works because we see that a, b, c, d multiplied by itself contains one each of all the numbers from 2 to 8. 2, 3, 4, 5, 6, 7, and 8. Therefore, this last possibility is the only way for a, b, c, d to satisfy all the constraints of the problem, leading to a being equal to 24, b being equal to 20, c being equal to 6, and d being equal to 14, as listed here. Therefore, we read off that a minus c is equal to 18.